say you get an A- on the report card. So, in a fit of rage, you decide to throw an electron against the wall. Now, what's going to happen to an electron? Well, common sense tells you that it's just going to bounce off the wall like a ball. However, there is a chance that the electron will teleport through the wall. This process is known as quantum tunneling. However, quantum tunneling is not the result of the electron breaking the wall, like how a bullet punches through a target, or electrons somehow creating a portal to the other side. In that case, why does quantum tunneling occur? To answer this question, we'll need to explore another concept in quantum mechanics: wave-particle duality. Now it is time to rethink the entire universe, because matter also has properties of waves. Waves as in ripples in water or sound waves traveling through air. For instance, I may be sitting on this chair recording this video inside my home in Fresno, California. But I'm also technically on the moon and the sun. And right next to you, creepily breathing down your neck. All at the same time. It's just that my wavelength is so small that the probability of me not being exactly where you expect me to be, sitting on my chair, is infinitesimally tiny. Same with the electron, except its wavelength is larger because the particle itself is smaller, so there is a higher probability of variance in its position. The electron you threw out the wall could be predicted to be everywhere, including the other side of the wall. Just that there is a certain probability for each outcome, so the electron could only be found on the other side of the wall during certain trials, each with a different position for the electron during each measure. Another example of quantum tunneling is in our sun, where nuclear fusion occurs. Nuclear fusion is basically just hydrogen atoms fusing to create helium atoms and a lot of energy. To understand nuclear fusion, you're going to need to know about the strong force and the electromagnetic force. Now, the strong force is what holds nuclei together. Keep in mind that it is relatively weak at large distances and extremely strong at short distances. And the electromagnetic force, think magnets. Electromagnetic force opposes the strong force in this case, as the protons in the hydrogen nuclei causes them to repel each other. To make fusion occur, we would really like to get the two hydrogen nuclei close to each other to fuse into helium for the strong force to take place, but we can't do that because the electromagnetic force from the two protons stops them from moving toward each other. This is where quantum tunneling saves the day. The protons are actually able to teleport to each other and allow the strong force to take control. Quantum mechanics holds the answer to nuclear fusion, which makes interstellar travel, clean energy for all, and Star Trek all possible. Thanks, quantum tunneling.